Hello everyone. I promised to put the answer to these two problems up on the website, and then I left school on Friday without them, and now I'm in a spot where I can't get back to pick them up. So I'll work them out real quick in a little movie here, and we'll talk through them. So the first problem involves aluminum being reacted with aqueous hydrochloric acid. This is really just a gas stoichiometry problem, and you would need to write the equation first. So you'd start with aluminum, and you'd add to that hydrochloric acid. I was expecting you to be able to look at the reactants and tell what the products are. Aluminum, this is a single replacement reaction, and aluminum would form a cation because if you look at the periodic table, it will have a positive charge. So it would replace the positive part of the HCl. So what you're going to end up with is aluminum combined with the chlorine, and then hydrogen will be by itself. Remember that hydrogen is part of Brinkelhoff, so you'd have H2, and the aluminum being plus 3 with the chlorine minus 1 would require AlCl3. At that point, you're ready to balance the equation, so you've got 3 Cl's. If I put a 3 in front of this, that would give me 3 H's as well. So the 3 in front would fix the Cl, but it wouldn't work for the hydrogen because there's 2 hydrogens over here. So you need to go to the next higher common multiple of 2 and 3, which is 6. So if I put a 6 there, then I could put a 2 here, which would give me 6 chlorines, and a 3 here. 3 times 2 is 6 H's. That does, however, mean that we have 2 aluminums on the right side, so I need to put a 2 over here. So that's your balanced equation. First question says you've got 500 grams of this. In order to make this problem look a little bit neater, I'm going to not show all of the work that I'm going to do here. So we're going to change 500 grams to moles, and I'm going to assume that you know how to do that. So I'm opening up my calculator on my cell phone that's sitting beside this little pad, and I'm going to do 500 times 1 mole over 27 grams, because 27 is the number of moles, or excuse me, the number of grams in a mole of aluminum. So I have here 18.5 moles of aluminum. For the acid, we're told that there are 8 liters, and there are 4 moles per liter. So we're really looking at 32 moles of HCl. So which runs out first? Because if we're going to find the volume of the gas, this is the gas, and we're looking for how many liters. So if we're going to find that, we need to first know how many moles of gas we have. Moles of gas are going to depend on whichever one of these two runs out first. So if you take one and compare to the other, and it really doesn't make any difference which one you pick. So if you started with the aluminum, 18.5 moles of aluminum, I multiply by the ratio of HCl to aluminum, which is 6 to 2. So really I'm going to have 18.5 times 3, which is 18.5 times 3 would be 55.5. That means we would need 55.5 moles of aluminum. Well, we don't have 55.5 moles of aluminum. We only have 32. Oops, I'm sorry, I just said the wrong thing. We have 55.5 moles of HCl because the aluminum cancels. Okay, and we don't have 55.5 moles of HCl. We have only 32 moles. So do we have enough HCl? No. So if we were going to use all of the Al, we would need 55.5 moles of HCl. We don't have 55.5, we only have 32. So that means the HCl is going to run out, and the aluminum will be excess. There'll be more of it than we need. So we take our 32 moles of aluminum, we multiply by the mole ratio between the hydrogen and the aluminum. So we're putting hydrogen on top, put aluminum on the bottom. There's 3 of these for every 2 of those. So 32 times 1.5 would be 48 moles of hydrogen. So we need to change it to, we need to find out how many liters that is. So I'm going to have to scroll down here. So to do that, I would suggest that you use PV equals nRT. I'll just squeeze it in right here. We know the moles of hydrogen, so PV equals nRT. The pressure, we can see up here, it's 1.2 atmospheres. So I need to change 1.2 atmospheres to millimeters of mercury because your chart that you have for water vapor pressures is in millimeters of mercury. So you put 1 atmosphere on the bottom, and you know that standard pressure in millimeters of mercury is 760. So we have to multiply 1.2 by 760. Which is 912. All right, now I'm at a disadvantage because I don't remember what the water vapor pressure is at 25 degrees C, and I don't have that chart in front of me. Maybe I can find it real quick here. So at 25 degrees, the water vapor pressure is 23.8. All right, so we'll go back over here. So that's 23.8. So we'd have 912. Subtracting 23.8 equals 888.2. So minus 23.8, oops, and that equals 888.2. So we'd have to use that for pressure, 888.2, and that's millimeters of mercury. All right, the volume, we don't know. We're trying to find that, so put a V there. All right, V, and the number of moles we know is 48. I'm going to eliminate units for the sake of space here. That's 62.4. So 62.4 goes here. And then the temperature is 25, we said. So that's 298. So 298 K. All right, so now we're going to say 48 times 62.4 times 298 equals, and then we're going to divide that number by 888.2. So I get a final answer of 1004, but that doesn't sound right to me, so let's double check that. So 48 times 62.4 times 298, this 298 right here, supposed to be an 8 there. So 298, oops. All right, equals, so now I got 888 no, I've got 48 times 62.4 times 298 equals, and then I'm going to divide that by 888.2, and I get 1005 moles, or liters. So V equals 1005 liters. I'm going to stop there for that part of the problem, double check all my math, and then we'll come back for part 2.